afternoon, students. In the last class, we are discussing about the escape velocity, right? So today we start with the new topic, that is satellites. Right? So what are satellites? Right? So satellites are the objects which are revolving around the planets, right? So that we call as the satellites, right? So satellite is an object which revolve around the planet in circular or elliptical path, right? So what is satellite? So satellite is an object which revolve around the planet in circular or elliptical path. Right. So this gives what the definition of the satellite, right? So what is satellite? So satellite is nothing but it is an object which revolve around the planet in circular or elliptical path, right? So again we can classify the satellites into two types. So one is natural satellite and another one is the artificial satellite. So artificial satellite is the man-made satellite, right? So moon is the natural satellite of the earth, right? So moon is revolving around the earth, right? So we have some more artificial satellites, right? So first we will discuss on orbital velocity of the satellite or orbital velocity of any object, right? So first definition, satellite, right? So satellite is an object which revolve around the planet, right? So it may be in any planet, right, which revolve around the planet in either circular path or elliptical path. So again satellites are classified into two types. So one is natural satellite and another one is artificial satellite. So artificial satellite further classified into geostationary satellite and polar satellite. So that will be discussed in our later classes, right? So next the topic is orbital velocity. So in the last class we discussed on the escape velocity. So escape velocity is the velocity with which the object will escape from the earth gravitational field. So that we call as the escape velocity, right? So with which the minimum speed it required to escape from the earth gravitational force, right? So here orbital velocity, so it is the velocity which required to revolve, that is the horizontal velocity which is required to revolve around the planet, right? So any object which is moving around the planet means it has some velocity, right? The horizontal velocity which it required to revolve around the planet, we call that velocity as the orbital velocity, right? The horizontal velocity required by an object to revolve around the planet, right? So the horizontal velocity required for an object to revolve around the planet, so in circular orbit, right? So in circular orbit. So we call that velocity as the orbital velocity. So there is a difference between the escape velocity and orbital velocity. So escape velocity is the minimum velocity which is required to escape from the Earth's gravitational force, right? So that velocity is the escape velocity, and orbital velocity is the velocity which is required by an object to move around the planet in a circular orbit, right? So here if we consider Earth as a planet, right? So Earth has mass that is ME, where ME represents the mass of the earth and RE is the radius of the earth. So considered an object, so object nothing but considered one satellite, right? So satellite is also an object. So object means it has also some mass. So we take that as M, right? So the satellite or an object which is at a distance h from the surface of the earth. So the ಎಷ್ಟು distance ಇದೆ ಅಂದ್ರೆ some distance we taken that distance as h, right? So what is responsible for the satellite to move around the circular path? So that is the horizontal velocity v, right? So velocity is a vector, it has two components, one is horizontal and another one is vertical, right? So the horizontal component of the velocity is responsible for the satellite to move in a circular orbit, right? So now we all object are considered ಮಾಡಬಹುದು, but here in this case we take on that object as satellite, right? So this is the circular orbit. Right. So as the satellite is moving in a circular path, so the radius of the circular path we taken from the center of the earth. So radius of the circular path is RE plus H. So RE plus H gives what? The radius of circular orbit. Right. So we take small r, that is equals to RE plus H. So which component is responsible for the object to move along the circular, that is move in a circular path? So that is the orbital velocity. So which component of velocity? That is the horizontal component, right? So we take VO. So VO is the orbital velocity. So orbital velocity is denoted by V suffix O, right? So here we need to find the relation for the orbital velocity in terms of acceleration due to gravity and also in terms of the gravitational constant, that is G, right? So as the object is moving in a circular path, so hence it experiences the centripetal force. So this is again from the Newton's laws of motion. So any object which is moving in a circular path, then it experiences a force. So that force is the centripetal force, and the force is always acts towards the center of the earth, right? So from that we can write the relation centripetal force which is experienced by the satellite or which is experienced by the object. So we take on that one as F, that is equals to, so centripetal force is mv square divided by r. So here the object is moving with the orbital velocity VO, so hence we take on m VO square divided by radius. So radius is how much? That is RE plus H. So that is from the relation centripetal force F, that is equals to mv square divided by r, right? So this relation we derived from the concept that is centripetal force. So ಯಾವುದಾದರೂ ಒಂದು object circular path ಅಲ್ಲಿ move ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, so there exists the centripetal acceleration. So as the object is moving with centripetal acceleration, so hence there is a force. So that force is the centripetal force. So centripetal force is responsible for the object to move in a circular path. So ಇದನ್ನ ನಾವು laws of motion ಅಲ್ಲೇನೆ study ಮಾಡಿದ್ವಿ, right? So that is we have the relation F is equals to mv square divided by r. So here we have the r value RE plus H. So hence we substitute RE plus H, right? So we call this one as the first equation, right? So here we have Earth. So Earth has mass ME and the satellite or an object which is also having a mass M, right? So the two objects which are separated by a distance, so hence the satellite experiences the gravitational force, that is from the Newton's law of gravitation, right? So from Newton's law of gravitation, the satellite experiences or satellite or object which experiences the gravitational force, right? Gravitational force F, that is equals to, so gravitational force, it is an attractive force which attracts towards the earth. So earth kadage enagta ide namage attract agta ide. Again from the relation we have F, that is equals to G into ME, where ME is the mass of the earth and small m is the mass of the satellite or object divided by square of the distance between the satellite and to the earth, right? So that is the distance between satellite and to the center of the earth. Again we can take that one as the radius, right? So that is RE plus H whole square. So we call this one as the second relation, right? So to find the horizontal velocity or orbital velocity, we are using the two relations. The first one is due to the centripetal force. That is again from the concept, ಯಾವುದಾದ್ರು object circular path ಅಲ್ಲಿ move ಆಗ್ತಾ ಇದೆ ಅಥವಾ move ಆಗಬೇಕು ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವ force responsible ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ that is because of the centripetal force. So by using this relation, we return the formula, that is F is equals to mv square divided by r, right? So again from this chapter, from the Newton's law of gravitation, we having two objects separated by a small distance or separated by a distance, then the object will experiences the attractive force, right? So here the satellite will experiences the force, right? So that is Fg, gravitational force, and Fc, centripetal force. So both are acting in towards the center of the earth, right? So from equation 1 and 2 we have LHS, that is force, so both are same, right? So LHS ಎರಡು same ಇರೋದ್ರಿಂದ we can equate the RHS, right? So we can write from equation 1 and 2. So from equation 1 and 2 in LHS we have the force, so we can equate in the RHS, right? That is m VO square divided by RE plus H, that is equals to G ME into small m divided by RE plus H whole square, right? So in the LHS we have small m, in the RHS we have small m, so we can cancel the mass of the satellite, right? So in the denominator RE plus H, in the RHS, in the denominator also we have RE plus H whole square, so one term get cancels, right? So the remaining is, so remaining we are getting VO square, that is equals to G ME divided by RE plus H, right? So where VO is the orbital velocity. So now if we compare RE, that is the radius of the earth, so we know the value of the radius of the earth, RE, that is equals to 6400 kilometer, right? So we are placing the satellite which is less than the value of radius of the earth. So H value is approximately, we can take some 500 kilometer to 800 kilometer, right? So this is for the polar satellites, right? So in polar satellites we are placing in the orbit which is revolving around the earth, so it has at a distance 500 kilometer from the surface of the earth, right? So if we compare the height to the radius of the earth, so 500 kilometer is very less compared to that of the 6400 kilometer, right? So considering that case, so H value is very less than the radius of the earth, right? So hence we can neglect the height value, right? So H becomes 0, so we get the orbital velocity VO square, that is equals to GME divided by RE, right? So we need VO, so VO is equals to under square root of GME divided by RE. So this is the final expression for the orbital velocity in terms of gravitational constant, that is G, right? So where G is gravitational constant, ME is the mass of the earth, and RE is the radius of the earth, right? So small m is the mass of the object, or here we can take this one as satellite, then m is the mass of the satellite, right? So this is the expression for the orbital velocity, right? So now the same orbital velocity we can also express in terms of acceleration due to gravity, right? So by using the same relation, VO, that is equals to under square root of G me divided by R, right? So multiply and divide numerator and denominator by the term RE, right? So this becomes the square root of GME divided by RE square into RE, right? So we know the value GME by RE square. So this value we can replace by the acceleration due to gravity. That is for the relation between G and capital G, right? So we can write that is root G into RE. So this is the orbital velocity in terms of acceleration due to gravity, right? That is because G is equals to GME divided by R, right? So where G is constant and radius of the earth is also constant, right? So ನಮಗೆ G value ಗೊತ್ತಿದೆ ಜೊತೆಗೆ RE value ಗೊತ್ತಿದೆ. So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get the VO orbital velocity of the satellite at a height. So that value is equals to 7.92 kilometer per second, right? So this is the standard value of the orbital velocity, right? So what is orbital velocity? It is the horizontal velocity which required for an object to revolve around the planet, right? So that velocity we call as the orbital velocity. To derive this relation, we require two concepts, right? So that is one is any object which is moving in a circular path, then the centripetal force is acting on that object, right? So that is the first relation, and the second relation is the object which is at a distance from the earth. So these two having the masses, so hence the object will experiences the gravitational force. So by using the gravitational force relation equating these two, we can obtain the relation G is V naught is equals to root of GME divided by RE, right? So this is the relation for the orbital velocity in terms of gravitational constant. So we need the orbital velocity in terms of acceleration due to gravity. So multiply and divide by the term RE. So we get GME divided by RE square into RE. So we can replace GME by RE square by G. That is due to because of the relation small g and capital G, right? So this is about the orbital velocity, right? So next, the relation between, before going to that one, time period of a satellite, right? Right. So what is time period? Time period is the time taken by the satellite to complete one rotation around the planet. Right. So that we call as the time period. Right. So what is time period? So time period is the time taken by the satellite to complete one revolution around the planet. Right. It is the time taken by an object or by a planet to complete one revolution around the planet, right? So ಅಲ್ಲಿ ನಾವು object place ಅಲ್ಲಿ we can replace by a satellite, object or satellite, right? So it is the time taken by an object or satellite to complete one revolution around the planet, right? So one complete revolution ಆಗುತ್ತೆ around the earth. So ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೋ ಅದನ್ನ ನಾವೇನಂತ ಕರೀತೀವಿ time period, right? So here the satellite is moving with a speed. So speed or velocity that we call as the orbital speed or orbital velocity, right? So orbital speed, that is equals to distance covered for one revolution, right? So distance covered for one revolution to the time taken, right? So we need time period t, right? So orbital speed, that is VO, that is equals to distance covered. So it covers the circular path, so hence the distance covered is the circumference of the circle. So we can take that one as 2 pi r, right, where r is the radius, right? So this r we can replace by re plus h, right? So 2 pi r divided by time that we call as the time period. So time period of a satellite we denoted by the capital T, right? So from this we can write T is equals to 2 pi r divided by VO, that is orbital velocity, right? So this is orbital velocity. If they ask time period in terms of capital G, so substitute VO here, right? So if in the ask for the time period in terms of small g, that is acceleration due to gravity, we have that relation also. VO is equals to square root of g into re, right? So here r is replaced by, that is 2 pi re plus h whole divided by VO, right? So for considering the cases, h is very small compared to re, so we can neglect the h value. So that becomes h is equals to 0. So substituting here 2 pi re whole divided by square root of g into re. That is for the time period. So in the numerator re is there, so we can write that re in terms of square root re into square root re, right? So that is 2 pi under root re into under root re whole divided by under root g. So in the denominator we can write this one root g into root re, right? So now we can cancel in the numerator 1 root re, in the denominator another root re. So final expression for the time period, time taken to complete one revolution around the earth, that is t is equals to 2 pi under square root re divided by g. This is the expression for the time period of a satellite, right? So orbital, first we find the value of orbital velocity VO, then the time period, right? So what is time period? Time taken by the object or time taken by the satellite to complete one revolution around the planet, right? So now moon anta consider ಮಾಡ್ಕೊಂಡ್ರೆ object as moon anta consider ಮಾಡಿದ್ರೆ earth na kuda ನಾವು ಒಂದು planet ಅಂತ ತಗೊಂಡ್ರೆ we can substitute the values re, we know the value of re and we know the value of g, right? So from that we can find the time period of an object to revolve around the satellite, that is revolve around the planet, right? So this is the time period of a satellite, right? So the next is relation between escape speed and that of the orbital speed, right? So the next one is relation between escape speed or escape velocity to orbital speed or orbital velocity, right? So in the last class we discussed about the topic, that is escape velocity. So in this today's topic we discussed about the orbital speed, right? So first we need to write the relation for escape speed or escape velocity, that is ve, that is equals to under square root of 2g or e, where g is the acceleration due to gravity and re is the radius of the earth, right? So and the second one is orbital speed or orbital velocity, that is denoted by VO, right? So VO is equals to under square root of G or E, right? So by observing these two relations, so VE we can write that one as root 2 into root of G or E, right? So ಇದನ್ನ ನಾವೇನು ಬರೀಬಹುದು, ರೂಟ್ 2 ಸಪರೇಟ್ ಆಗಿ ಬರ್ಕೊಂಡು ರೂಟ್ ಆಫ್ ಜಿ ಆರ್ ಇ ಅಂತ ಬರೀಬಹುದು, ರೈಟ್? ಸೊ ಫ್ರಮ್ ದ ಆರ್ಬಿಟಲ್ ವೆಲಾಸಿಟಿ ರೂಟ್ ಜಿ we can write, so v is equals to root 2 times vo. So this is the relation between escape speed to the orbital speed, right? So relation between escape speed and to the orbital speed ಕೇಳ್ತಾ ಇರ್ತಾರೆ ನಮಗೆ 2 marks ಗೆ, right? So simple is that first we need to write the two relation. First one of escape speed ಗೆ relation, in the last class we derived this relation. So we need to write the relation in terms of acceleration due to gravity g, right? So same way orbital speed also we have derived in this class, that is v is equals to root r in g into re, right? So by observing these two relations, or we can divide first equation by second equation, so we get ve by is equals to root 2 into root 2 into root gre divided by root gre. So numerator and denominator root gre get cancelled. So from that we can write ve is equals to root 2 times of vo. So ನೀವು ಅದನ್ನ ಯಾವ ತರ ಬೇಕಾದರೂ represent ಮಾಡ್ಕೋಬಹುದು, right? So here in this relation, first relation, second, so this is from 1, right? So first relation we can write this relation, right? So this is the relation between escape speed and to that of the orbital speed, right? So next, trajectories of the body when moving different speed, right? Trajectories of the body when moving with different speeds, right? So trajectory is nothing but the path traced by an object when it is moving with different speeds, right? So ಇದು trajectories ಅನ್ನೋ word ನ ನಾವು motion in a plane ಕೂಡ ಯೂಸ್ ಮಾಡಿದ್ವಿ, right? So projectile of an object is parabola. So ಯಾವ trajectory path follow ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ that indicates what the parabolic path, right? So here also we are discussing the trajectory of the body, right? So that is satellite which is moving with a different speed. So ಬೇರೆ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದು ಯಾವ ಪಾತ್ ನ ಫಾಲೋ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನ here we are going to discuss. That is again by using the two relations. One is escape speed ve, that is equals to under root 2 into g e, right? So this is the first relation, and relation orbital speed, that is equals to under root g r e, right? Right? So VO is the orbital speed and V is the escape speed, right? So VO orbital speed, ಈ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋದ್ರೆ ಮಾತ್ರ ಈ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ, it will trace the circular path, right? So first case 1, if the object is moving which is less than the speed that of the orbital velocity, right? So orbital velocity ಗಿನು ಲೆಸ್ಸರ್ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ಪಾತ್ ನ ಟ್ರೇಸ್ ಮಾಡ್ತಾ ಇದೆ, right? So if the object is moving with some velocity v which is less than that of the orbital speed, right? For example, orbital speed we found the value that is 7.92 kilometer per second, right? So that is the standard orbital speed. So if the object is moving or revolving around the planet which is less than that of the orbital speed, right? So orbital speed is nಮಗೆ 7.92 kilometer per second ಇದೆ, right? So that is the value for VO. If the object is revolving around the planet lesser value than that of the orbital speed, that means if the value v naught is some 5 kilometer per second, right? So the object 5 kilometer per second alli move agokke start aitu andre what it happens, so this is the minimum speed to revolve around the planet, right? So ಈ ಸ್ಪೀಡ್ ಏನಿದೆ ಅಂದ್ರೆ ಮಿನಿಮಮ್ ಸ್ಪೀಡ್, ಇದಕ್ಕಿಂತ ಲೆಸ್ಸರ್ ಆಯ್ತು ಅಂದ್ರೆ it will fall down to the earth, right? So when the speed of the object which is less than that of the orbital speed, right? So the object will fall down when the object is moving with a speed which is less than that of the orbital speed, or in other words v is less than under root g r e, right? So this is the first case, right? So next, second case, if the object is moving with a speed that is equals to g r e, right? So ivaga object enagta ide move aagta ide, so with the speed that is equals to 7.92 kilometer per second, right? So ee speed alli yavadru object move aagta ittu andre so then it traces circular path. The object traces circular path, right? So this one is the second case, right? So first case alli enagutte lesser value ittu andre 7.92 kilometer per second inu kadme value alli hogta ittu andre the object will fall down to the planet. So a planet mele object enagta ide beelta ide, right? So second case alli when the object is moving with the speed 7.92, so ide value alli object move agak start aitu, that means revolve agak start aitu andre it will traces the circular path, right? So next, case 3, if the object is moving which is equal to that of the root 2 GRE, that means the object is moving with the speed of escape velocity, right? So v is equals to v, or in other terms that is equals to 2GRE, right? So here also if the object is moving which is less than the escape speed, then also the object will fall down, right? So then in the class alli kuda explain madidvi yavadru object escape speed ಗಿನ ಕಮ್ಮಿ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋಯ್ತು ಅಂದ್ರೆ it will again fall ground, or again it falls to the earth surface, right? So escape speed ಎಷ್ಟಿದೆ ನಮಗೆ e is equals to 11.2 kilometer per second, right? So if the object is moving with this speed, escape speed ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ then the object will traces the elliptical path, right? The object traces elliptical path, adu circular path ಆಗಿರೋದಿಲ್ಲ, so that is traces the elliptical path. So ಯಾವ shape ಅಲ್ಲಿ move ಆಗುತ್ತೆ ಅಂದ್ರೆ it will move in an elliptical shape, that means ellipse shape ಅಲ್ಲಿ it will move around the planet, right? So when the object is moving with the speed of root 2 GRE, that means 11.2 kilometer per second speed alli hoytu andre the object will traces the elliptical path, right? So on the last case, in the case 4, the object is moving with a speed which is greater than ve, right? So escape speed ginu ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಮೂವ್ ಆಯ್ತು ಅಂದ್ರೆ then object will traces the parabolic or hyperbolic path, right? So when v is greater than 2g re, then object traces hyperbolic path, right? So ಅದಕ್ಕಿಂತ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋಯಿತು ಅಂದ್ರೆ the object will leave from the earth gravitational field, right? So this is circular path. So this one is the elliptical path and this one is the hyperbolic path, right? So these are the trajectories which is followed by an object which is moving with a different speed. So different speed under two cases. One we taken the reference as orbital speed and another one we taken as the escape speed, right? So ಎರಡು ಕೇಸಲ್ಲೂ the object which is moving less than the escape speed and less than the orbital speed, then the object will fall down, right? So because 5 km per second alline ಹೋಗ್ತಾ ಇದ್ರು fall ಆಗ್ತಾ ಇದೆ compared to the escape speed. So escape speed ಎಷ್ಟಿದೆ 11 ಇದೆ, right? So 5 is less than 7 and also 11. So hence the object will fall down, right? So satellite ಏನಾಗುತ್ತೆ ನಮಗೆ ಕೆಳಗಡೆ ಬೀಳುತ್ತೆ. So ಯಾವಾಗ ನಮಗೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಟ್ರೇಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ when the object is moving with the speed of root g or e, right? So when the object is moving in an elliptical path, when the object is moving with the speed of escape velocity, right? So when the object will traces the hyperbolic path, when the object is moving greater than the escape velocity, right? So these are the trajectories which followed by the object when it is moving with different speeds, right? So next, energy of the satellite. So that we will discuss in our next class. So ಇಲ್ಲಿ ಕೂಡ ನಮಗೊಂದು relation ಇದೆ, right? So energy of the satellite. In the next class also we will discuss on the different types of satellites. That is artificial satellites ಅಲ್ಲಿ ಮತ್ತೆ two types ಇದೆ. One is geostationary satellite and another one is the polar satellite, right? So that we will discuss in our next class. Thank you.